So here are the answers to the questions at the end of the previous chapter. Why don't you pause the video and tick them off? Hope you got them all right. The Earth's crust. So what's the structure of the Earth? We have the core, which consists of the outer and inner core. This is about half the radius of the Earth, and the core contains nickel and iron, which are both magnetic. The next layer out is the mantle, which is about 3,000 kilometers thick, and this can flow slowly. We then have the crust on the outside. This is between 5 kilometers in some places and 70 kilometers thick in others, and it's cracked in places like a jigsaw puzzle. And the important thing to remember is that the Earth, the oceans and the atmosphere are our only sources of materials. You need to learn both the structure, the order of the layers, and the relative sizes of each layer. Alfred Wegener was famous because he was the first person to suggest in 1915 that the continents are moving. He was the first one to come up with the idea of continental drift. He couldn't explain how though, and so other scientists just didn't accept his ideas. And it wasn't until more than 50 years later when scientists discovered that in places the sea floor is separating and spreading apart and magma is rising up through the gap, that they found evidence that Wegener was right. So now we tend to accept his idea. So what is continental drift? Now, there are natural radioactive processes in the Earth's core which release heat. Now this sets up convection currents in the mantle, which, although it's mostly solid, it is able to flow. And these convection currents cause the cracked pieces of crust, called tectonic plates, to move slowly. And when we say slowly, we mean a few centimetres a year. Don't get mixed up about earthquakes and volcanoes. Volcanoes are openings or ruptures in the Earth's crust where the molten rock or magma is able to escape. Earthquakes, however, are sudden, powerful movements of the tectonic plates caused by convection currents of the mantle driven by heat from radioactive processes. What they do have in common is that both are found at the boundaries between tectonic plates. Predicting earthquakes. Now, scientists continually monitor zones of earthquake activity and volcanic activity. They look for signs of imminent earthquakes or volcanic eruptions. The trouble is they make many predictions every year which thankfully don't always come true, but it means that governments don't always want to act upon them because it causes widespread panic. The scientists can't accurately predict earthquakes because they can't see what's going on under the crust, and they can't predict how strong the earthquake will be nor exactly where the earthquake will take place. Okay, time to test yourself then. Away you go. Good luck.